8.2, the Pythagorean theorem and its converse. So the first thing we're going to talk about is right triangles. And right triangles are triangles that have a 90-degree angle in them. Parts of a right triangle, we have the hypotenuse, which is directly across from the 90 degrees. So here's our 90 degrees in the corner. The directly opposite side is our hypotenuse. That's always the longest side. And the other two sides are called the legs. For the Pythagorean theorem, which you guys have seen before, is a squared plus b squared is equal to c squared. So it's leg squared plus leg squared is equal to hypotenuse squared. So c is our hypotenuse. Okay. So for these, we're going to find our missing side using that theorem. So it's always a good idea to label what you're considering a, b, and c. C is always directly across from the 90 degrees. A and B, it doesn't really matter which one's which as long as you have C correct. All right, so we have 6 squared plus 15 squared is equal to x squared. That's going to give us 36 plus 225 is equal to x squared. We're going to get 261 is equal to x squared. And when I take the square root of that, I'm going to get a decimal, so that's going to give me about 16.2. We can do the same thing over here. Directly across from the 90 degrees is my hypotenuse, and then it doesn't matter which one's A or which one's B. We have x squared plus 9 squared is equal to 11 squared. So that's x squared plus 81 is equal to 121. We'll subtract from both sides. We're going to get x squared is equal to 40. And then I'm going to square root both sides. Again, getting a decimal, no big deal. X is about 6.3. All right, so for the next one, we have x, 9, and 12. And again, directly across from the 90 degrees is going to be my hypotenuse. And then it does not matter which one I call A or which one I call B. A squared plus b squared equals c squared. So 12 squared plus 9 squared is equal to x squared. That's 144 plus 81 is equal to x squared. That's going to give us 225 is equal to x squared. And then I'm going to take the square root and I'm going to get that x is equal to exactly 15. All right, over here, same concept. Directly across from my 90 degrees is my C. Otherwise, it doesn't matter which is A or B. X squared plus 12 squared is equal to C squared, which in this case is 13. So we have x squared plus 144 is equal to 169. I'll subtract from both sides. I'll get that x squared is equal to 25. When I square root both sides, I'm going to get x is equal to 5. So if you notice, those last two problems worked out very nicely. I had integers as my parts that were given to me, and my answers were integers. When that happens, those are special Pythagorean triples, or multiples of Pythagorean triples. So Pythagorean triples are positive numbers that fit that a squared plus b squared equals c squared equation. The most common examples you'll see are 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, and 17. And most are just multiples of those guys. Now, it's just kind of nice because they're numbers you'll start to recognize as you see the Pythagorean theorem used more and more. The 3, 4, 5 is really the most common one you'll see. It's because it's easy and small numbers to use for textbook problems in general. All right, so we can also kind of use this Pythagorean theorem to tell us a little bit more information. So if we have a squared plus b squared is equal to c squared, we can assume we have a right triangle. So this is the converse. First, we said before, if we have a right triangle, then a squared plus b squared equals c squared. Now we're saying if a squared plus b squared equals c squared, then we have a right triangle. So it's just the reverse, the converse. So that's true. If it's equal, we're going to get a right triangle. If c squared is smaller than the sum, we're going to have an acute triangle. And if c squared is greater than the sum, we are going to have, whoops, I apologize, that should say an obtuse triangle. Okay. And what we mean by that is this angle is over 90 degrees, and all of the angles here are acute. All right, so we want to determine what is going on here. Do I have an acute, a right, or an obtuse triangle given these side measures? So I'm going to look for the largest number. The largest number is going to be my C. So the largest number here is 14. That's my C. It doesn't matter what's the rest of them. So let's find out what's C squared and what's A squared plus B squared, and then we'll compare them. So C squared, that's 14 squared. Over here we have 7 squared plus 6 squared. All right, 14 squared is 196. Here we have 49 plus 36. So we have 196. 49 plus 36 is 85. So it's clear that C squared is larger. That tells me that we have an obtuse triangle. And that's really just by the rules up top there. Okay. So for the next one, again, look for your largest side. That's going to be your C. So we have 41 squared. We want to know what happens when we do 9 squared plus 40 squared. 41 squared is 1681. We have 81 plus 1600. So 1681, this adds to 1681. Those values are equal. So since they are equal, that means we have a right triangle. Okay. For the next one, we have 6, 4, and 5. 6 is the largest number here, so that's going to be my C. So we have 6 squared, we have 4 squared plus 5 squared. That's 36. That's 16 plus 25. So we have 36 on the left. 16 and 25 is going to add to, let's see, 41. 41 is larger, so C squared is smaller. That's going to be this, where we have an acute triangle. And last but not least, maybe it's not so obvious. What we could do is use a calculator if we needed to figure out which of these was the largest. So we could type in to find out what is 2 square root of 3 equal to. And 2 square root of 3 is about 3.46. Let's see, the 4 square root of 2 is about 5.66, and 3 square root of 5 is about 6.71. Okay, so this is going to be our largest. 6.71 is bigger than the others. Okay, so that's my C. So I have 3 root 5 squared. I can absolutely use the calculator to help me out here. On the other side, I have 2 root 3 squared plus 4 root 2 squared. Okay, we can absolutely do this in our calculator. So let me switch over to my calculator real quick. Whoops. Of course it wants me to try to update. It's always asking to update. Okay, so here we go. We need 3 root 5 squared. So I'm going to use parentheses to make sure I am squaring the whole thing. So let's square that. We're going to get 45 when we do that. For the other two, we have 2 root 3 getting squared. And then we want to add to that 4 root 2 being squared. And that's going to give me 44. So the C squared gives me 45. When I add the other side, I get 44. So this is giving me 45. This adds to 44. 45 is greater. So since C squared is greater, we are going to have an obtuse triangle.